Hello students, in this video we'll discuss the last and important topic in the chapter thermodynamics, that is entropy. You have already studied what is enthalpy and this is entropy. Okay, that is enthalpy and this is entropy. Both the terms are different. Okay, so we'll study about entropy with an example. Okay, just see the image. You can see two boxes there, box 1 and box 2. Okay, so in box 1 you can see blue color dots and red color dots. So assume these dots as gaseous molecules, okay, gas molecules. So let the blue color dots, let it be gas A molecules, and red color dots, let it be gas B molecules. Okay, so gas A and gas B. Blue is gas A, red is gas B, and it is enclosed in a container, and there is a movable partition also in between them. Okay, now if I ask you to take a gas molecule from the left side of the container, okay, from the left side of the container, if I ask you to take a gas molecule, it would be sure that these molecules will be of gas A. The molecule which you're going to take will be of gas A. Now if I ask you to take a molecule from the right side of the container, okay, from the right side of the container, if you take a gas molecule, it is for sure that you're going to take the gas molecule of gas B, isn't it? So if you take from the left side, it will be gas A. From the right side, if you take, it will be of gas B. Now if you remove that movable partition from there, what will happen? These gas molecules start to diffuse each other, that is, they'll mix, isn't it? So you can see, you can observe the figure, that is box 2. You can see both the gases, that is gas A and gas B, both will mix, that is, they will diffuse to each other, isn't it? Now from this box, that is from box 2, if I ask you to take a gas molecule, okay, if I ask you to take a gas molecule, which gas molecule will you get? It is like a confusion, isn't it? We are not sure whether the molecule you picked is gas A or gas B. We can't say that because both are there, isn't it? So we can say that the system has become less predictable. That is, we cannot predict whether it is a gas A or gas B. So the system has become less predictable, or it has become more chaotic. Chaotic means it has become more disordered. Okay, so at this point of time, we are going to introduce another thermodynamic function, that is called as entropy. Okay, we have come across a new term in thermodynamics, that is called as entropy. And entropy, it can be what is say defined as a measure of the degree of randomness or disorder in the system. That is, how much disordered the system is, that much entropy is there. That is, if the system is more disordered, then the entropy of the system will be more. That is, when the disorder is more, entropy is more. That is how you define entropy. That is the degree of disorder or degree of randomness in a system. That is entropy. And the symbol of entropy, it is denoted as S. Okay, enthalpy, it was H, capital H. Symbol of entropy is capital S. Okay, these terms you have to remember, it is very important. Enthalpy is capital H, entropy is capital S. Okay, now these are some examples for entropy. You can see the first one, that is highly ordered structure. It is like a solid. Okay, highly ordered structure, once they become disordered, like a gas molecule or like liquid, what happens? Disorderness is more, so the entropy is more. Okay, when it is ordered, you can see highly ordered and entropy is less, low entropy. When it is more disordered, entropy is more, high entropy. Now you can see the example of ice cubes and water. Okay, so actually this is like solid and liquid. When it is solid, you know that the ions or the molecules, they are orderly arranged, isn't it? So there is no randomness. Molecules are in a fixed position, they don't have randomness, so the entropy is less, there is no disorder in that. So they have less entropy. When it comes to liquid, these molecules, they are little more free to move than in solid. So what happens is, when they are free to move, they are disordered, they'll be like keep on moving, so they are disordered, their randomness is more, so their entropy is more, isn't it? So you can see another example also. When it is different, when it is not ordered, it is high entropy. When it is ordered, it is low entropy. Okay. Now you can see another example where it is orderly arranged, it is of low entropy because disorder is less. When it is more disordered, the entropy is more. This is another example: high randomness, high entropy, and high disorder. That is, when the randomness is more, when the disorder is more, entropy is more. When it is orderly arranged, what happens is randomness is less, disorder is less, then entropy is also less. Now if you consider solid state, it is all what you say ordered arranged, isn't it? Ions or molecules, they are orderly arranged, so entropy will be less. And if you consider the gaseous state, it will be having the highest entropy because gases, they are disordered, they have high randomness. Okay, high degree of randomness. Now uh, now we'll study the last topic, that is Gibbs energy and spontaneity. That is how Gibbs energy and spontaneity, it is connected. Okay, so you just have to study this equation, that is delta G is equal to delta H minus T delta S. Like how you have studied for enthalpy, you have to remember this formula also, that is delta G is equal to delta H minus T delta S. So delta G is the Gibbs free energy, delta H is the change in enthalpy, delta S is change in entropy because it is delta, so change in entropy or change in enthalpy. Then T is temperature in Kelvin. Okay, now how this what do you say, delta G, how it gives a criteria for spontaneity is at constant pressure and temperature. If the value of delta G, if it is less than 0, okay, if it is less than 0 or if it is negative, the delta G value, if it is negative, then the process is spontaneous. That process will be a spontaneous process. Spontaneous means those which occurs naturally, we don't have to supply any external support. Okay, so it will occur by itself. Now if the value of delta G, if it is equal to 0, then the system is at equilibrium. Okay, system is at equilibrium. Now if the value of delta G, if it is positive or if it is greater than 0 means it is positive value, then those processes will be non-spontaneous. That is, we have to supply some external energy, or you have to give some external support for that reaction to occur. So if delta G is negative, it is a spontaneous reaction or process. If delta G is positive, it is a positive, then it is a non-spontaneous process. So you have to remember this formula, that is delta G is equal to delta H minus T delta S, and this criteria also for delta G: if it is negative, it is spontaneous; if it is positive, it is non-spontaneous process, for your next year. Okay, so with this we have completed this chapter of thermodynamics. In the next class we'll be beginning the next chapter. Thank you.